Welcome to Quartus 2 software tutorial. We're first going to start by clicking the Quartus 2 icon on the desktop. We're going to learn first how to create a new project. To do so, go to File, go to New Project Wizard, and click on the Next button. For the directory of the project, always go to your computer, local C, and D Labs. Click Open. For the name of the project, put the required name you need. I'll be putting Full Adder. Click on the Next once you're done. Click on Next again. Now for the family of devices, put Flex 10K. And for the device that we'll be using, EPF 10K 70RC244. After you're done selecting, click on the Next button. Click on Next again. Now you'll see the summary. Once you see that, click on Finish. Now we've created a new project called Full Adder. Now to create a block diagram file, go to New, go to File, go to New, Block Diagram Schematic File, and press OK. Now always save the file first. So you go to File, Save As, and click Full Adder and press Save. Now once we're done, to import the products, we go to double-click on the screen, open the file, go to Primitive, go to Pin, and you can see your input and output pins are required. By simply clicking and dragging them again, you can copy them. Similarly, do it for all the products. You can even find a device by simply typing its name. Wires can be created as shown in the tutorial. Always make your circuit diagram very neat and tidy. Once you're done, don't forget to click the Save button again. Now for giving the pin names, you simply double-click on the name and change it as shown in the tutorial. I'm doing it similarly for the output. Now after clicking on the Save button, I'm going to set this project as a top level entity. This is really important in the project. Now I'm going to select the analysis icon on the top bar. It was successful, that means no errors. Now I'm going to simulate. So I'm going to Processing, Simulator tool. The simulation mode is always going to be functional. And I'm going to generate the simulation netlist. Click on the OK once it's successful. Now we're going to create a waveform file. So go to File, New, click on Vector Waveform File, and click OK. Save it under the same name that you created for the block diagram file. Now double-clicking on the white space and clicking Node Finder and List, you'll find all the nodes that are in your circuit diagram. Once you're done adding them to the node list, click OK. Now I'm rearranging them according to how I need by simply clicking and dragging on them. Now we'll go to Edit and End Size. The end size depends on your input. For me it will be 800 as I have 3 inputs. I'll also adjust the grid size by going to Edit, Grid Size, and putting 100 nanoseconds. Once I'm done, I'm going to go to View and Fit in Window. Now to change the values by simply selecting an area that I require and clicking a 1 or a 0, the values can be changed. The values can also be changed by highlighting a signal and clicking on the C and pressing OK. Once you're done, don't forget to save it. Now go to Processing Simulator tool again, put the file that you just did, and now we're going to start the simulation. The simulation was successful. Click on OK and click the Open button once you're done. This is the required simulation file that you need. Now we're going to go to create a new symbol. So to do so, first click on the full adder block diagram file, go to File, Create and Update, Create Symbol Files. I'm going to save it as FA and click Save. Now we'll open a new block diagram file to use the symbol that we created. So first we create a new project. Do the same steps as we followed in the beginning. So we click Next. You put the name of the project. I'm going to put it as Adder 3. Click Next again. Next. The family and the device name select and press Finish. Now we'll go create a new block diagram file. Now by double-clicking on the screen and pressing Project, you'll see your device that you just created. Use the device in the circuit. As you can see, I'm creating a bus by writing as I have done. Now I'm doing the connections as required. As you can see, I'm naming the connection. So now by extending the wire, and once it's highlighted, type whatever name that you need to give the wire. And that will be the input for it. You don't have to connect the input physically. You can even, from the input, extend a wire and extend a wire from the device, and it will make a connection, as shown in this circuit diagram. Now, as you can see, these input and output wires, they are thicker than usual. These are called buses. They are a group of many signals or inputs. Now, after saving the file, I'm going to go to set it as a top level entity, and then I'm going to do my analysis. It was successful. Now, like earlier, I'm going to simulate it. So you go to Processing, Simulation Tool, change the mode to functional, and generate it. Once it was successful, click on the OK button. Now we'll go and create a waveform by clicking on the vector waveform file as shown before. Save the file in the beginning. Then by double-clicking on the space and clicking Node Finder and List, you'll get all the list. By simply clicking on the double arrows, it will come into your space, and click OK. Now you can see, as I mentioned before, buses A, B, and S are a collection of 3 inputs. By changing the end time and the grid size, click OK. Go to View, Fits in Window. Once you're done, give any inputs that you need or provided by your instructor by simply highlighting and double-clicking and changing the value. In this example, I'm giving any four values to A and to B. Now once I'm done, I'm going to save it as usual and then go to the Processing and Simulator tool. I'm going to add the file into the simulation input, and then I'm going to start the simulation by clicking on the Start button. Once it's done and there is no error, I'm going to open the file to see my output. This is the output that is required. Thank you for listening to Quartus 2 software tutorial.